Question 4. Solve the equation 5z upon 1 plus 2I minus z into z conjugate plus 30 plus 10I is equal to 0, giving your answers in the form x plus iy where x and y are real. So we have an equation where we have z, our complex number, and we have to give our answer in the form x plus iy where x and y are real. So first what we look at is we look at in the equation we have z, but in our answer we have to give it in the form x plus iy. So in the start what we do is we write down z in a form of x plus iy. So we write let z is equal to x plus iy, and if z is equal to x plus iy, then the conjugate of z would be x minus iy. So now we have z and x z conjugate. So now we can put that into the equation. So 5z becomes 5 into x plus iy upon 1 plus 2i. Now we have 1 plus 2i as a denominator here, but we cannot have 1 plus 2i as the denominator because 2i is an imaginary number. And we cannot have that as the denominator because we have to put it in the form x plus iy. So if there's an imaginary number as a denominator, that means that we cannot have this x as a constant. Okay, so we'll have to rationalize this, and we do that by multiplying 1 minus 2i to both the numerator and the denominator. Then after that we have minus z into z conjugate, so x plus iy into x minus iy plus 30 plus 10i equals 0. So let's get this out of the way. We have 5x plus 5iy upon, and this is in the form a plus b into a minus b. This 1 plus 2i right here, and this 1 minus 2i right here. This is in the form a plus b into a minus b. Also this x plus iy and this x minus iy. Both of these pairs are in the form a plus b into a minus b. And we already know that a plus b into a minus b, this is equal to a square minus b square. This is a very basic identity we have, so this makes things simple for us. We don't have to calculate. So it's 1 square minus 2i whole square, and on the top is obviously going to be multiplied by 1 minus 2i, and then we put this, so it's x square minus iy whole square plus 30 plus 10i. So what we have to keep in mind here is that I square is equal to minus 1. Okay, so this minus iy whole square over here and this minus 2i square over here, we will substitute the values of I square as minus 1, so we can make this into a constant and take out the imaginary. So it would become 1 square is 1, so 2i whole square is 4i square. 4i square is equal to minus 4. Now we also have a minus sign in front, so this minus 4 becomes a minus 4. So this ultimately becomes a 1 plus 4. For the numerator, it's 5x plus 5y into 1 minus 2i. So we'll write that down as 5x minus 10xi plus 5iy minus 10yi square. Now since this is an I square here also, we'll just take this into plus and we'll cross out the I square. And then we have this, so it's x square. This is y square, so y square I square, so it becomes an x square plus y square plus 30 plus 10i is equal to 0. So now let's try to take out this fraction. We have 5 in the denominator, and at the top we have everything is a multiple of 5. So we have 5x minus 10xi plus 5iy plus 10y, and this is the fraction minus x square minus y square plus 30 plus 10i is equal to 0. Let's remove this fraction. So 5x becomes x, 10xi becomes minus 2xi plus 5iy becomes plus iy, plus 10y becomes plus 2y, minus x square minus y square plus 30 plus 10i is equal to 0. Now we have this equation and we've removed all the fractions. So what we'll do is that since the right hand side is equal to 0, that means both the real parts and the imaginary parts of this polynomial of this equation have to be 0. So the real parts, let's just underline this: x is real, 2y is real, x square, y square, 30, these are all real parts, and the imaginary parts are this, and this. So first let's deal with the imaginary parts since there are less of those. So minus 2xi plus iy plus 10i is equal to 0. If we take the I common, so it's I, so minus 2x plus y plus 10 is equal to 0. So y plus 10 is equal to 2x, y is equal to 2x minus 10. Now we have the right hand side, we now have the constant part, so the real part. So we have, let's make a line, so x plus 2y minus x square minus y square plus 30 is equal to 0. Let's substitute using our value of y as 2x minus 10. So x plus 4x minus 20 minus x square plus 30, and we'll add this y square value. Sorry, we'll subtract this y square value. So 2x minus 10 whole square becomes 4x square plus 100 minus 40x. So we have that, and this all is equal to 0. So let's now try to simplify this. 5x plus 10 minus x square minus 4x square minus 100 plus 40x is equal to 0. We simplify this further, minus 5x square plus 45x minus 90 is 0. Now we take the minus 5 common. So x square minus 9x minus 18, sorry, plus 18 is equal to 0. From here we split the middle term. So x and 18, we have to have a middle term that has a multiple. When you multiply both the terms together, it becomes 18. And since the signs are same, positive, positive, they should add up to get 18. So on the top of my head, I can think of 3 and 6. So x square minus 3x minus 6x plus 18 is equal to 0. Because when you add 3 and 6 together, it becomes a 9. And when you multiply 3 and 6, it becomes an 18. So that's how you split the middle term. So then x minus 3 minus 6, x minus 3 equals 0. So from there, we get x minus 3 and x minus 6 equal to 0. So x is equal to 3, x is equal to 6, and from there we calculate using our values of y using this equation that we found on top, this 2x minus 10. So when x is 3, 2x is 6, minus 10 is minus 4, and when x is 6, 2x is 12, minus 10 is 2. So now we have our two sets of values. And keep in mind, in the question itself, it says giving your answers. So see how this is plural, so they want multiple answers. So that's one way you can double check. So since our format is in the form x plus iy, z is equal to x plus iy, so our first answer is 3 minus 4i. This is our first answer. And our second answer is 6 plus 2i. So now we have two answers, 3 minus 4i and 6 plus 2i.